Hi, in this video we're going to talk about half-life. To find half-life, we're going to use half-life formula. And that is 1/2 of A0 is equal to A0 times e to the kth power. And now A0 is this initial value. E is the constant on your calculator, it's just an E. And then t is time, and k is a constant that you have to look for. Alright, and then there are two steps. Step 1, find k by using what's given. And now step 2, substitute k back into the formula and solve for what you need. So let's do an example of half-life. So our problem here states the half-life of 232Th is 1.4 times 10 to the 10th power years. If there are 25.0 remaining in a sample after 2.8 times 10 to the 10 years, how many grams were in the original sample? So you're going to use what you're given into the formula. So let's see. So we have 1/2. We're looking for original, so we're going to use x over here is equal to x. Actually, we could divide both sides by x, and the x wouldn't even exist over here. So 1/2 is equal to e times the half-life. T should be the original half-life. T is the time of original half-life. Time of half-life. So over here, time of half-life is 1.4 times 10 to the 10th power, and k. So we're going to use... So to solve this, we're going to have to use log. Log base of e is equal to... No, log base of e of 1/2 is equal to 1.4 times 10 to the 10th power k, which means ln of 1/2 divided by 1.4 times 10 to the 10th power e to the 10th power and that should give us x. No, we're looking for k. K is equal to negative 4.9510513 times 10 to the negative 11th. And this step is basically, instead of writing log, I can write ln. And this step is basically from pre-calculus. No, math 3, where you learn how to work with logs. So now that we found k, we're going to replace k in the original sample. So 1/2 of x is equal to x times e to the 1.4 times 10 to the 10th power times negative 4.95 times 10 to the negative 11th power. So 1/2 x is equal to, let's see. Oh, now we're going to use the second part of... Now that we found t, we're going to use the second half of what we're given and replace k in the formula as well. So after 25 years, there are x times e to the... No, there are 25 grams remaining after x times e to negative 4.95 times 10 to the negative 11th. So over here, we're going to replace the t. We found the k, and now we're going to substitute the new t and the new value that we got. So times the time, which is 2.8, times 10 to the 10th power. So e to the negative 4.95 e to the negative 11th times 2.8 e to the 10th gives us 25 is equal to x times 0.25. Divide both sides by 0.25. We should get 25 divided by 0.25, 100? 100. X is equal to 100 grams. So in the original sample, there are 100 grams. Now let's do another example. There are 5.0 gram of 131I after 40.35 days. 131 is just telling you the weight. Remember in the previous video we said A over Z, and instead of writing Z, it didn't need to write it because we should know what Z is, which is 53, since Z is the atomic number. Alright, but that's not really important. So what was the mass of the original sample if the half-life is 8.07 days? So first we define K using the original half-life, but we're not sure what the original half-life is, so we're going to substitute it with X, and X gets cancelled, so we don't really need X. 1/2 is equal to E to the 8.07, which is time, times K. So we can use this to find K, which is ln of ln of 1/2 divided by 8.07 is equal to K. So ln of 0.5 divided by 8.07 gives us K is equal to negative 0.08589. Now we're going to use the second part we're given of the information that we're given. There are 5 grams after 40 days. So instead of writing 1/2 X, we're going to write 5 grams is equal to X, which is what we're looking for, times, delete that, X times E to the 40.35 days, right? 43.35 days, which is time, times K, which is negative 0.08589. Alright. Now with that, we can easily find what this number is equal to. 5 is equal to E to the 40.35 times negative that gives us 0.03125x. Divide both sides by 0.03125. And we are going to get 160 grams. So the final to this is 160 grams. So again, steps are very simple. First, we're going to use 1/2 of A0 is equal to A0 E K to the T. A0 and A0 cancels out depending on what you're looking for. We're looking for the original sample, which is A0. That's why the A0 and A0 cancels out. But if I told you the original sample, you want to find something else, you're going to keep the A0s. And then your job is to find K first. After you found K, you're going to substitute K back into the equation using another part of the information you're given. Like over here, in the beginning, we're given the original half-time, and then we plug that in using something else we were given, like 25 grams remaining after this many days. And then after that, we just do algebra using our calculator, and we can find value of X, which is what we're looking for. Thank you for watching.